What if I told you that right now, as you're sitting there watching this video, you're actually floating through an ocean of invisible waves and curves that are constantly stretching, compressing, and rippling around you? What if the very fabric that holds our universe together was suddenly as visible as the air we breathe on a foggy morning? Tonight, we're going to take a journey into one of the most mind bending thought experiments in all of physics. We're going to imagine a world where space time itself becomes visible to the human eye, where the hidden architecture of reality suddenly reveals itself in all its strange and beautiful glory. Now, I know what you're thinking. Space time? Isn't that just some abstract concept that Einstein dreamed up? Something that only exists in textbooks and equations? Well, prepare to have your mind completely shifted, because space-time is as real as the ground beneath your feet. In fact, it is the ground beneath your feet, and the air around you, and the emptiness between stars. It's everything and everywhere, the stage upon which every single moment of your life unfolds. But here's where it gets fascinating. What we're about to explore isn't just some wild science fiction fantasy. Understanding what space time would look like if we could see it gives us incredible insights into how gravity actually works, why time passes differently in different places, and how the universe itself is structured at the most fundamental level. Before we dive deep into this visual feast of cosmic proportions, I want you to know that everything I'm about to show you is grounded in real physics. We're not just making pretty pictures here. We're using the actual mathematics of Einstein's general relativity combined with decades of experimental evidence to paint a picture of reality that's more spectacular than any movie special effect. And trust me, by the end of this video, you'll never look at an empty space the same way again. You'll understand why physicists get so excited about black holes, why GPS satellites have to account for the flow of time, and why the universe is expanding in ways that would make your head spin if you could actually see it happening. So let's begin this journey into the invisible realm that surrounds us all. Picture this. You wake up one morning, and as you open your eyes, the world has changed in the most extraordinary way imaginable. The air around you isn't just transparent anymore. Instead, you can see it, but not as a gas or vapor. You can see the actual structure of space itself, stretching and flowing like a three-dimensional river of light and shadow. At first glance, it might look like you're underwater, surrounded by a gentle, shimmering medium that extends in every direction. But this isn't water, and it's not really flowing in the way you'd expect. This is space-time, and it's more like a vast, flexible membrane that fills every corner of existence. Now, the first thing you'd notice is that this membrane isn't flat. Oh no, it's anything but flat. Everywhere you look, you'd see gentle curves and slopes, like rolling hills in a cosmic landscape. And these curves aren't random. They follow a precise pattern, a geometry that tells the story of every massive object in the vicinity. Look down at your feet. The earth beneath you would appear as a massive depression in this space-time fabric, like a bowling ball placed on a stretched rubber sheet. The curvature would be subtle but unmistakable, creating a gentle funnel that extends far beyond the planet's surface. This depression, this warping of space-time itself, is what we call gravity. It's not a force pulling you down, it's the very geometry of reality guiding your motion along the straightest possible path through curved space. But here's where it gets really wild. As you look around, you'd see that you're not just passively observing this space time motion, you're part of it. Your own body, with its mass and energy, creates its own tiny dimple in the fabric. It's incredibly small compared to the Earth's massive depression, but it's there, a little wrinkle in reality that announces your presence to the universe. Now imagine you could see your friend standing next to you. Their body would create its own small depression, and here's the beautiful part. These depressions would actually attract each other, not through some mysterious force reaching across empty space, but because the geometry itself guides objects to roll toward each other along the curved paths of space-time. This is gravity revealed in its true form, not as a pull, but as a consequence of geometry. But we're just getting started. Look up at the sky, and the visual feast becomes even more incredible. The sun, that massive ball of nuclear fire, creates a depression in space-time so deep and broad that it influences everything within millions of miles. If you could see space-time, the sun would appear as a tremendous well in the fabric of reality, its edges sloping down so dramatically that light itself has to follow the curved paths around it. And those curved paths of light, well, that's where things get really interesting. You'd see streams of photons, visible as rivers of light, following the contours of space-time like water flowing down a hillside. When light passes near the sun, you'd actually watch it bend, following the curved geometry of space-time around the massive object. This isn't science fiction. This is exactly what happens in our universe, and we've measured it countless times during solar eclipses. But perhaps the most mind-blowing sight would be watching time itself become visible. Yes, time. In this space-time visible world, you'd see that time flows differently in different regions. Near massive objects where space-time is more curved, time would appear to flow like thick honey, slow and viscous. Further away, where space-time is flatter, time would flow like clear water, quick and unimpeded. Imagine watching a clock sitting on a massive object. From your perspective, you'd see the clock ticking slower, the hands moving through a medium that's literally thicker with gravitational time dilation. Meanwhile, a clock floating in the relatively flat space-time far from any massive objects would tick away at normal speed. Time itself has texture, density, a visible quality that changes based on the curvature of space-time around it. This isn't just theoretical. GPS satellites orbiting high above Earth actually experience time flowing slightly faster than clocks on the surface, and the satellite systems have to constantly correct for this difference. If space-time were visible, you'd see exactly why this happens. The satellites float in a region of space-time that's less curved by Earth's gravity, so time flows more freely there. Now, let's talk about motion. In our space-time visible world, moving objects would create the most spectacular displays you could imagine. When you walk forward, you'd see yourself carving a path through the space-time medium, creating tiny ripples that spread outward from your body. These ripples, these gravitational waves, are real phenomena that we've only recently learned to detect with incredibly sensitive instruments. But imagine if you could move really fast, approaching significant fractions of the speed of light. The space-time around you would begin to compress and stretch in dramatic ways. In front of you, space-time would appear compressed, squashed together like an accordion. Behind you, it would stretch out, elongated and thin. This is length contraction and time dilation made visible, the very fabric of reality reshaping itself in response to your motion. And if somehow you could reach the speed of light, well, the view would become truly surreal. Space-time ahead of you would compress to an infinitely thin sheet, while behind you it would stretch to infinite length. Of course, nothing with mass can actually reach light speed, but photons, those massless particles of light, experience exactly this perspective as they race through the universe. Speaking of light, in our visible space-time world, you'd see something absolutely magnificent. Light wouldn't just be rays shooting through empty space. You'd see light as streams of energy following the natural highways of space-time, taking the shortest possible routes through the curved geometry of reality. Near black holes, these light streams would spiral inward, creating beautiful, terrifying whirlpools of photons caught in the extreme curvature of space-time. But here's something that would really blow your mind. You'd see that space and time aren't separate things at all. They're woven together into a single, unified fabric. When you move through space, you're also moving through time, and the faster you move through space, the slower you move through time. This exchange between spatial motion and temporal motion would be visible as a kind of cosmic dance, a constant trade-off between moving through the dimensions of space and the dimension of time. Picture yourself running as fast as you can. In normal vision, you'd just see yourself moving quickly through space. But in space-time vision, you'd see yourself moving more slowly through time, as if the universe were compensating for your increased spatial motion by reducing your temporal motion. The faster you run through space, the slower you'd see yourself moving through time. This is why nothing can go faster than light. Light moves through space at maximum speed, which means it doesn't move through time at all. From a photon's perspective, its entire journey from a distant star to your eye happens instantaneously. It experiences no passage of time whatsoever. If space-time were visible, you'd see photons as frozen in the time dimension, moving only through space, like cosmic messengers that exist outside the normal flow of temporal progression. The implications of all this become even more extraordinary when we consider larger scales. Look beyond our solar system, and you'd see the space-time fabric stretching across vast distances between stars. But it's not empty or flat. It's filled with gentle waves and ripples, gravitational disturbances created by massive objects accelerating through space. When two black holes spiral into each other billions of light years away, they create ripples in space-time that travel outward at the speed of light. If you could see space-time, you'd watch these ripples pass through our solar system like gentle waves on a cosmic pond. We've actually detected these gravitational waves with instruments like LIGO, but imagine if you could see them with your own eyes, watching the very fabric of reality flex and flow as cosmic events reshape the universe on the grandest scales. Now let's zoom out even further and explore what might be the most breathtaking vista of all. If you could see space-time on a cosmic scale, you'd witness the universe itself breathing, expanding, and stretching in ways that would fundamentally change how you understand existence itself. Picture yourself floating in the depths of space, far from any galaxy or star. Around you, the space-time fabric would appear relatively smooth, but not perfectly flat. Instead, you'd see it gently expanding in all directions, like the surface of a balloon being inflated in slow motion. This is cosmic expansion made visible, the very reason why distant galaxies appear to be racing away from us at incredible speeds. But here's what would really astound you: the galaxies aren't actually moving through space at these tremendous velocities. Instead, the space between them is growing, stretching like taffy being pulled apart. You'd see galaxies sitting relatively still in their local patches of space-time, while the fabric itself carries them apart. It's as if the universe is a vast piece of stretchy material with coins glued to its surface, and someone is pulling the material in all directions. The coins themselves aren't sliding across the surface, they're being carried along as the material expands. This expansion isn't uniform everywhere, though. In regions where matter is dense, where galaxies cluster together, you'd see the space-time fabric resisting expansion, held together by the collective gravitational influence of billions of stars. These cosmic neighborhoods would appear as relatively stable islands in an ocean of expanding space, connected by vast bridges and filaments of dark matter that you'd see as subtle variations in the space-time texture. And speaking of dark matter, if space-time were visible, you'd finally see this mysterious substance that makes up most of the mass in our universe. It doesn't emit light, doesn't interact with ordinary matter in ways we can easily detect, but it absolutely curves space-time. You'd see vast halos of invisible mass surrounding galaxies, creating gentle depressions and flows in the space-time fabric that guide the motions of stars and gas clouds. These dark matter structures would appear as ghostly scaffolding throughout the cosmos, invisible to normal light, but clearly imprinted in the geometry of space-time itself. You'd watch ordinary matter flowing along the paths carved out by dark matter's gravitational influence, like rivers following valleys carved by ancient glaciers. But perhaps the most mind expanding sight would be observing how different regions of the universe experience time differently. In areas where space time is relatively flat and smooth, time would flow at what we might consider a normal rate. But near massive galaxy clusters, where space time is deeply curved by the combined gravity of trillions of stars, time would crawl by comparison. Imagine watching two identical atomic clocks, one floating in the vast emptiness between galaxy clusters, another sitting near the center of a massive galactic supercluster. You'd see the clock in curved space-time ticking noticeably slower, its hands moving through the thick, honey-like texture of highly warped space-time. Meanwhile, the clock in empty space would tick away normally in the thinner, less curved regions of the cosmic fabric. This means that if you could live in both locations simultaneously, you'd age at different rates. The version of you in curved spacetime would experience less time passing, aging more slowly relative to the version floating in empty space. It's not just a theoretical curiosity, it's a fundamental feature of how time works in our universe. Now, let's consider what happens when space-time itself gets torn or damaged. Near the most extreme objects in the universe, like spinning black holes or colliding neutron stars, you'd see space-time stretched to its breaking point. The fabric would appear twisted and tortured, curved so severely that it creates regions where the normal rules of geometry break down completely. Around a spinning black hole, You'd watch space-time itself being dragged around in circles, like honey being stirred by a cosmic spoon. This frame dragging effect would be visible as spiral patterns in the space-time fabric, regions where the very coordinate system of space and time gets twisted into helical shapes. Objects falling toward the black hole wouldn't just follow straight radial paths, they'd be carried along by these spiral currents in space-time itself. At the event horizon of a black hole, something truly extraordinary would happen to your vision of space-time. The curvature would become so extreme that space-time would appear to fold in on itself, creating a boundary beyond which you literally cannot see. It's not that light gets absorbed, it's that the geometry of space-time becomes so warped that the very concept of beyond loses meaning. But even more fascinating would be watching time near the event horizon. You'd see time dilation taken to its absolute extreme. Imagine watching a clock fall toward a black hole. As it approaches the event horizon, you'd see it ticking slower and slower, the hands moving through space-time that becomes increasingly curved and compressed. From your distant perspective, the clock would appear to freeze completely at the event horizon, its final tick stretched out over eternity. Yet, from the clock's perspective, if it could somehow transmit its experience back to you, it would pass through the event horizon normally, experiencing time at its usual rate. This creates a profound paradox in the visual appearance of spacetime. The same events would look completely different depending on where you're observing from, highlighting how spacetime isn't just curved, it's relative. Let's shift our perspective to something even more mind-bending. What if you could see spacetime at the quantum level, where the smooth fabric we've been imagining breaks down into something far more chaotic and strange? At incredibly tiny scales, smaller than anything we can currently measure, spacetime itself might not be smooth at all. Instead, you'd see what physicists call quantum foam, a seething mass of virtual particles popping in and out of existence, creating tiny fluctuations in the spacetime fabric. At these scales, space and time would appear to bubble and writhe like boiling water, with the smooth geometry we observe at larger scales emerging only as a statistical average of countless quantum fluctuations. These quantum effects would be invisible at human scales, but imagine if you could zoom in far enough to see them. Space-time would appear to have texture, like looking at a smooth lake surface that reveals choppy waves when you examine it closely. The very concepts of distance and duration would become fuzzy and uncertain, governed by the strange rules of quantum mechanics rather than the elegant geometry of general relativity. This quantum foam might even connect distant regions of the universe through tiny wormholes, microscopic tunnels in space-time that constantly form and dissolve. You'd see the universe as interconnected at its deepest level, with every point in space potentially connected to every other point through these fleeting quantum bridges. But let's return to scales we can better imagine. One of the most beautiful sights in our space-time visible universe would be watching the dance of binary objects. Two stars orbiting each other would create an intricate pattern of gravitational waves rippling outward through the spacetime fabric. You'd see these waves as concentric circles of compression and expansion, like ripples on a pond, but in 3 dimensions and carrying away energy from the orbiting system. As the stars slowly spiral closer together, losing energy to these gravitational waves, the ripples would become more frequent and intense. The final moments before collision would create a crescendo of space time distortion, with waves so powerful they'd be visible as dramatic flexing and stretching of the fabric itself. And when the stars finally merge, you'd witness one of the most violent events in the universe made visible in space time. The collision would send shockwaves rippling outward at light speed, carrying the signature of the merger to every corner of the universe. These gravitational waves would pass through planets, stars, and even other black holes, barely interacting with matter but clearly visible as disturbances in the space-time medium. The aftermath would be equally spectacular. A newly formed black hole would settle into its final configuration, and you'd watch space-time itself ringing like a struck bell, vibrating with characteristic frequencies that depend on the black hole's mass and spin. These oscillations would gradually decay, and space-time would smooth out into the perfect geometry of a stationary black hole. Throughout all of this cosmic drama, you'd notice something profound about the nature of information in the universe. Every event, every collision, every motion leaves its mark on the space-time fabric. Gravitational waves carry information about their sources encoded in their patterns of compression and expansion. The curvature around massive objects tells the story of how they formed and evolved. In a sense, space-time itself becomes a vast recording medium, preserving the history of every significant event in the universe's past. The gravitational waves from the first black holes formed after the Big Bang are still traveling through space today, carrying information about the universe's earliest epochs. If you could see space-time and trace these waves back to their sources, you'd be looking at a cosmic fossil record written in the geometry of space and time itself. This brings us to perhaps the most profound realization of all. In our space-time visible universe, you'd see that matter and energy don't just exist in space and time, they are space and time. Every particle, every wave of energy, every quantum field contributes to the curvature and flow of the space-time fabric. The distinction between empty space and filled space would completely dissolve. What we think of as vacuum, as nothingness, would reveal itself as a dynamic, ever-changing medium filled with virtual particles, quantum fluctuations, and the constant exchange of energy and information. Space wouldn't be a container that holds things, it would be the things themselves, expressed as patterns in the universal fabric of space-time. You'd begin to understand that consciousness itself might be intimately connected to this space-time fabric. As you observe this visible universe, you'd realize that your very thoughts and perceptions are creating tiny ripples in the medium around you. The electrical activity in your brain, the quantum processes that generate consciousness, they're all forms of energy that curve space-time in their own minuscule ways. Imagine watching yourself think. You'd see delicate patterns of neural activity creating microscopic disturbances in the space-time around your head, like watching thoughts themselves disturb the fabric of reality. When you remember something, when you make a decision, when you experience an emotion, each of these mental events would register as subtle changes in the local geometry of space and time. This wouldn't just be philosophical speculation. The energy involved in neural processes, however small, contributes to the stress energy tensor that determines space-time curvature. You'd be witnessing the physical manifestation of mind interfacing with the fundamental structure of reality itself. Now let's explore something that would completely revolutionize your understanding of causality and free will. In this space time visible world, you'd see that cause and effect aren't the simple linear progression we imagine. Instead, they'd appear as complex networks of influence spreading through the curved geometry of space-time. When you drop a ball, you wouldn't just see it falling down. You'd see the entire causal structure of the event laid out in space-time geometry. The ball's motion would be determined by the curvature created by Earth's mass, but that curvature extends infinitely outward, connecting your simple action to the gravitational influence of every other object in the universe. You'd see that every event is simultaneously a cause and an effect, embedded in an intricate web of space time relationships that stretch across cosmic distances and time scales. The butterfly effect wouldn't just be a metaphor about chaos theory, it would be visually apparent as tiny disturbances in space-time propagating outward and interacting with the curved paths created by distant galaxies. But here's where things get truly mind-bending. You'd discover that the future isn't separate from the past in the way we normally think. In space-time, all events that ever were or ever will be exist simultaneously in what physicists call the block universe. Past, present, and future would be visible as different regions of a four-dimensional landscape that you could potentially observe all at once. Imagine standing at a high vantage point and looking across this temporal terrain. You'd see your entire life history laid out like a winding path through space-time, from birth to death, with every moment existing as a real, physical location in the four-dimensional fabric. Your past selves wouldn't be gone, they'd be visible in the earlier regions of your world line. Your future selves wouldn't be non existent, they'd be there in the forward sections of space time, as real as your present moment. This would raise profound questions about the nature of time and existence. If all moments are equally real, what gives the present moment its special quality? Why do we experience time as flowing from past to future when all of space-time exists simultaneously? You'd be confronting the deepest mysteries of consciousness and temporal experience while literally seeing the architecture of eternity spread out before you. The implications for understanding death would be equally profound. In normal vision, death appears as an ending, a cessation of existence. But in space-time vision, death would simply be the boundary of a person's world line, the edge of their path through the four-dimensional fabric. The person's entire existence would remain embedded in space-time forever, as permanent and real as a mountain or a river. Every conversation you've ever had, every moment of joy or sorrow, every instance of love or discovery would be visible as permanent features in the landscape of space-time. Nothing would ever truly be lost because everything that happens leaves an indelible mark on the geometry of reality itself. Let's shift perspective to something more immediately practical. In your space-time visible world, you'd finally understand why Einstein's theories led to technologies like GPS satellites and particle accelerators. You'd see how engineers and physicists learned to work with the curvature of space-time rather than against it. GPS satellites would appear as objects carefully positioned in regions of space-time where time flows at specific rates. The system works by comparing time signals from multiple satellites, and you'd see how the slight differences in gravitational time dilation between satellites and ground based receivers create the triangulation data that pinpoints your location. But more than that, you'd see how the entire GPS constellation is essentially a machine for measuring the shape of spacetime around Earth. Each satellite is constantly probing the local curvature, sending back data about how time flows at its particular altitude and velocity. The GPS system is literally mapping the gravitational field of our planet by measuring variations in the flow of time. Particle accelerators would reveal themselves as devices for creating extreme curvatures in spacetime on microscopic scales. When physicists accelerate particles to near light speed, you'd see the spacetime around these particles becoming dramatically compressed and distorted. The high energy collisions that create exotic particles would appear as violent disruptions in the fabric itself, briefly creating conditions similar to those that existed in the first moments after the Big Bang. You'd watch as particle beams race around the accelerator rings, each particle carrying its own bubble of severely curved spacetime. When these bubbles collide, they'd create spectacular fireworks in the spacetime fabric, generating new particles from the pure energy released when highly curved regions of spacetime suddenly flatten out. Even more fascinating would be observing how these particle interactions reveal the deep connection between matter and geometry. You'd see that particles aren't really objects in the classical sense. They're persistent patterns of curvature in spacetime, standing waves in the cosmic fabric that maintain their shape while propagating through the universe. An electron wouldn't appear as a tiny sphere orbiting an atomic nucleus. Instead, it would look like a complex interference pattern in spacetime, a quantum wave function made visible as probabilistic ripples in the fabric of reality. When electrons jump between energy levels in atoms, you'd see these patterns suddenly reconfigure themselves, releasing photons as that excess curvature radiates away in the form of electromagnetic waves. The atomic nucleus itself would appear as an incredibly dense knot in spacetime, where the strong nuclear force creates such extreme curvature that protons and neutrons are bound together despite their electromagnetic repulsion. You'd see the delicate balance between the various forces of nature, expressed as competing geometries, each trying to shape spacetime in its own characteristic way. Now let's explore what might be the most psychologically challenging aspect of spacetime vision. You discover that simultaneity, the concept of events happening at the same time, is completely relative. Two events that appear simultaneous to you would not appear simultaneous to someone moving at high speed relative to your position. Imagine watching a friend traveling at significant velocity relative to you. From your perspective, you'd see their entire experience of simultaneity skewed compared to yours. Events that you perceive as happening at the same time would be spread out across different moments in your friend's reference frame. Their present moment would slice through space-time at a different angle than yours. This relativity of simultaneity would be visible as different observers, having different definitions of what constitutes a horizontal slice through the four-dimensional spacetime fabric. Your present moment and your friend's present moment would be oriented differently in the temporal dimension, like two people looking at the same landscape from different angles. The implications would be staggering. You'd realize that there's no universal now, no cosmic present moment that applies everywhere in the universe. Instead, the present is a purely local concept, defined by your state of motion relative to other objects. The universe doesn't have a single timeline. It has countless overlapping timelines, each equally valid from its own perspective. This would fundamentally challenge your intuitive understanding of existence and reality. If there's no universal present, then in what sense do distant events exist or not exist? If simultaneity is relative, then causality itself becomes a more complex and subtle phenomenon than we normally imagine. You'd see that the universe is far stranger and more beautiful than our everyday experience suggests. Reality isn't a series of moments unfolding in time. It's a vast four-dimensional sculpture where every event that ever happens is permanently carved into the architecture of space-time itself. And perhaps most remarkably, you'd understand that you're not separate from this cosmic sculpture. You are part of it, your consciousness weaving through the temporal dimension, just as your body moves through the spatial dimensions. Your awareness of the present moment is like a flashlight beam illuminating different cross sections of your four-dimensional existence as it progresses through time. In this space-time visible universe, the boundary between observer and observed would dissolve completely. You wouldn't just be watching the cosmic dance of matter and energy through curved space-time. You'd see yourself as an integral part of that dance, your very act of observation creating ripples in the fabric you're trying to perceive. The universe would reveal itself not as a machine made of separate parts, but as a single, unified entity where every component influences every other component through the medium of curved spacetime. Your thoughts, your movements, your very existence would be visible as contributing threads in the vast tapestry of cosmic geometry. This is the universe that Einstein glimpsed through his equations, the reality that lies hidden beneath our everyday perceptions. If space-time were visible to human eyes, we wouldn't just see the world differently, we'd understand our place in the cosmos in a completely new way. We'd see that we're not just observers of the universe, we're active participants in its ongoing creation, our every moment adding new patterns to the infinite complexity of space-time itself. But what would happen if we could manipulate what we see? In this space-time visible world, you'd discover that technology could become something far more profound than we've ever imagined. Instead of building machines that work against the fabric of reality, we'd learn to craft devices that work with space-time itself. Picture engineers designing spacecraft that don't fight against gravity, but instead surf the natural curves of space-time like cosmic surfers riding gravitational waves. You'd watch these vessels slip effortlessly along the contours of curved space, using the geometry itself as their propulsion system. They wouldn't need massive fuel tanks or powerful engines. They'd simply follow the most efficient paths through the warped landscape of space and time. The most elegant ships would appear to dance through space-time, their hulls designed to create specific patterns of curvature that guide them along predetermined routes. You'd see them weaving between planets and stars like dolphins riding ocean currents, using the natural ebb and flow of gravitational fields to accelerate and change direction. But here's where things get truly revolutionary. In regions where space-time is particularly malleable, perhaps near certain exotic matter configurations or artificial gravity generators. You'd watch engineers actually sculpting the fabric of reality itself. They'd create zones where time flows faster or slower on demand, regions where the normal rules of physics bend to human will. Imagine factories where time dilation is used as a manufacturing tool. You'd see production lines where certain processes happen in accelerated time bubbles, while quality control occurs in slowed time zones, where inspectors have what feels like hours to examine products that are actually manufactured in minutes of outside time. The same work that once took days could be completed in hours, not through faster machinery, but through the manipulation of time itself. Medical facilities would become even more extraordinary. You'd watch surgeons operating in carefully controlled temporal fields, where their hands move through regions of slowed time while their patients exist in synchronized time bubbles. Complex operations that normally require split second timing would unfold with the precision of slow motion choreography, giving doctors the luxury of extended moments to make critical decisions. Recovery rooms would feature healing zones where time flows differently for different parts of the patient's body. Injured tissues would be bathed in accelerated time fields, allowing months of natural healing to occur in days, while the patient's consciousness remains in normal time, preventing the psychological strain of experiencing accelerated recovery. But perhaps the most mind expanding technology would be temporal communication systems. You'd see messages being sent not just across space, but across time, using carefully crafted curves in spacetime to route information through loops that bring it back to earlier moments. These wouldn't violate causality, but they'd create communication networks that transcend our normal understanding of sequence and order. Imagine watching data streams flowing through space-time like rivers of light, taking scenic routes through curved regions that allow information to arrive before it was sent, at least from certain perspectives. Scientists could receive the results of experiments before completing them, not to violate causality, but to optimize their experimental designs in ways that create stable causal loops. Educational institutions would be transformed beyond recognition. You'd see students learning inside temporal classrooms where subjective hours of instruction fit into objective minutes of real time. A semester's worth of coursework could be completed in a weekend, not through cramming, but through the luxury of extended temporal experience within compressed time frames. Libraries would become four-dimensional archives where books and data exist across multiple temporal coordinates. You'd watch researchers accessing information, not just from different locations, but from different moments, studying how knowledge evolved across time by literally visiting the moments when discoveries were made. Art and entertainment would explode into dimensions we can barely imagine. Musicians would compose symphonies that exist in multiple time streams simultaneously, with different instruments playing in different temporal flows that converge into harmonies impossible to create in linear time. You'd see concerts where the audience experiences hours of music that unfolds across minutes of real time, or conversely, where brief musical phrases are stretched into lengthy emotional experiences. Sculptors would work with space-time itself as their medium, creating artworks that exist as four-dimensional structures visible only to those with space-time sight. These temporal sculptures would change and evolve as you move around them, not just in space but in time, revealing different aspects of their beauty depending on when and where you observe them. Writers would craft stories that exist as actual paths through space-time, narratives that readers could literally walk through, experiencing the plot from different temporal perspectives. You'd see people exploring novels like vast landscapes, choosing which character's timeline to follow, which moments to revisit, which futures to explore. But all of this technological wonder would pale in comparison to the profound changes in how we understand consciousness and identity. In your space time visible world, you'd see that individual minds aren't isolated entities floating in emptiness, but rather complex patterns woven into the fabric of reality itself. Each person's consciousness would appear as a unique signature in space-time, a characteristic way of creating ripples and responses in the cosmic fabric. You'd see thoughts not as abstract mental events, but as actual physical processes that leave measurable traces in the geometry around each person. When two people have a conversation, you'd watch their mental patterns interacting through space-time, creating interference patterns where their thoughts overlap and influence each other. Deep emotional connections would be visible as resonances in the fabric, synchronized vibrations that link minds across space and time. Love would reveal itself as a genuine physical phenomenon, a harmonization of space time patterns that creates stable, mutually reinforcing loops between conscious beings. You'd see couples who've been together for decades developing shared space time signatures, their individual patterns so intertwined that they function as a single, more complex entity. Family relationships would appear as networks of connected patterns, with parents and children sharing characteristic space time resonances that persist across great distances and long periods of separation. The bonds between siblings would be visible as parallel tracks through the temporal dimension, similar patterns following related paths through life. But here's where things get deeply philosophical. You'd begin to question whether individual consciousness is really individual at all, or whether what we think of as separate minds are actually different aspects of a single, vast consciousness that permeates all of spacetime. You might see that every conscious being is like an instrument in a cosmic orchestra, each playing its own part in a symphony of awareness that spans the entire universe. Individual thoughts and experiences would appear as local variations in a universal field of consciousness, temporary eddies in an infinite ocean of mind. This wouldn't diminish the importance of individual experience, but it would place it in a much grander context. You'd understand that your personal consciousness is both utterly unique and intimately connected to every other conscious being that has ever existed or ever will exist. Death would be revealed not as an ending, but as a transition in the pattern of consciousness as it's woven through space-time. You'd see that while the local concentration of awareness that constitutes an individual personality may fade, the patterns it created in the fabric of reality remain forever, influencing future conscious beings in subtle but measurable ways. The thoughts you think, the love you give, the kindness you show, all of these would be visible as permanent modifications to the structure of spacetime itself. Every act of consciousness would leave its mark on the cosmic fabric, ensuring that nothing truly conscious is ever truly lost. You'd also discover something remarkable about the nature of free will. In this space time visible universe, you'd see that choice isn't an illusion, but it's also not what we normally think it is. Your decisions would appear as places where multiple possible futures branch off from a single present moment, each choice creating a different trajectory through the four-dimensional landscape of space-time. But here's the twist. You'd see that all possible futures exist simultaneously in the space-time fabric, like different paths through a vast garden. What we experience as choice is actually the process of consciousness, selecting which path to follow, not creating the path itself. This would lead to a profound realization about the nature of possibility and actuality. Every choice you don't make would still exist as a real path through space-time, followed by other versions of your consciousness that made different decisions. The multiverse wouldn't be a science fiction concept. It would be visible as the natural branching structure of space-time itself. You'd see your life not as a single thread through time, but as a vast tree of possibilities, with your experienced reality following just one branch, while all the others remain equally real in their own right. Every moment of indecision would be visible as a branching point, where space-time splits into multiple futures, each as valid and real as the others. This would completely transform how you think about regret and missed opportunities. Every path not taken would still exist somewhere in the space-time manifold, followed by alternate versions of yourself that made different choices. In a sense, every possible version of your life is actually being lived simultaneously across the full structure of space-time. But perhaps the most profound transformation would be in how you understand purpose and meaning. In a universe where space-time is visible, you'd see that consciousness isn't just an accidental byproduct of complex matter arrangements. Instead, you'd see consciousness as an integral part of the space-time fabric itself, as fundamental as matter and energy. The universe would reveal itself as not just a physical system, but as a vast information processing network with conscious beings serving as nodes in a cosmic computation that spans billions of years and countless galaxies. Every thought, every decision, every moment of awareness would be visible as contributing to some greater purpose that transcends individual understanding. You'd see that the evolution of consciousness throughout cosmic history isn't random, but follows patterns and trends that suggest the universe is gradually becoming more self-aware, more capable of understanding and directing its own development. Stars, planets, life, intelligence, technology, all of these would appear as steps in a vast process by which spacetime itself is learning to know and transform itself. The search for meaning in life would be revealed as actually a search for your role in this cosmic awakening. You'd see that every conscious being has a unique contribution to make to the universe's growing self-awareness, a piece of the puzzle that only they can provide. Your individual experiences, no matter how ordinary they might seem, would be visible as essential data points in the universe's ongoing experiment with consciousness. Every joy and sorrow, every triumph and failure, every moment of confusion and clarity would appear as valuable information that helps spacetime understand itself more completely. And in the end, you'd realize that seeing spacetime isn't just about gaining a new perspective on physics or cosmology. It's about understanding your place in the vast, interconnected web of existence that spans all of space and time. You'd see that you're not a separate observer looking at an external universe, but an integral part of the universe observing itself, a temporary concentration of cosmic awareness embedded in the eternal fabric of space-time. The universe would no longer seem like a cold, indifferent expanse of matter and energy. Instead, it would reveal itself as a living, conscious entity of which you are an inseparable part. Every moment of your existence would be visible as a contribution to the cosmos's ever growing understanding of its own nature and possibilities. In this space time visible world, science and spirituality would merge into a single, unified understanding of reality. The equations of physics would be revealed as descriptions of the universe's consciousness, exploring its own mathematical nature, while spiritual insights would be seen as intuitive glimpses of the same cosmic self awareness that physics approaches through careful measurement and logical deduction. You'd understand that the ultimate goal of both science and spirituality is the same: to help the universe know itself more completely. Every scientific discovery and every moment of spiritual insight would be visible as steps in this grand process of cosmic self discovery. And perhaps most beautiful of all, you'd see that this process has no end. The universe's capacity for self understanding appears to be infinite, which means that consciousness, creativity, and discovery can continue forever, with each generation of conscious beings contributing new insights and perspectives to the eternal adventure of existence exploring itself. In seeing space time, you wouldn't just be observing the universe, you'd be participating in its ongoing creation. Your very act of perception adding new patterns to the infinite tapestry of reality. The cosmos would no longer be something that happened to you, but something you're actively helping to create with every moment of conscious awareness. This brings us to perhaps the most extraordinary revelation of all. In our space time visible universe, you discover that what we call empty space isn't empty at all. Between the massive depressions created by stars and planets, between the flowing rivers of light and the gentle ripples of gravitational waves, you'd see something that would fundamentally change how you think about nothingness itself. The vacuum of space would shimmer with activity, not the gross movements of matter and energy that we're used to seeing, but the subtle dance of virtual particles constantly popping into existence and annihilating themselves in the quantum foam of spacetime. These fleeting ghosts would appear as tiny sparkles in the fabric, like fireflies blinking in and out of reality so quickly that they barely register. Yet their collective effect shapes the very structure of the universe. You'd watch as particle pairs emerge from apparent nothingness, borrow energy from the space-time field itself, exist for the briefest possible moment, allowed by quantum uncertainty, and then disappear back into the void. But they don't disappear without leaving a trace. Each virtual particle leaves its mark on the local curvature of spacetime, contributing to what physicists call the vacuum energy, the restless activity that fills every cubic centimeter of seemingly empty space. Near the event horizons of black holes, this quantum activity would become dramatically visible. The intense curvature would stretch the brief lives of virtual particles just long enough for some of them to become real. You'd see one particle from each virtual pair falling into the black hole while its partner escapes into space, creating a steady stream of radiation that slowly evaporates the black hole over cosmic time scales. This is Hawking radiation made visible, the process by which even the most permanent seeming objects in the universe eventually dissolve back into the quantum foam from which they emerged. But the quantum nature of space-time would reveal itself in even stranger ways. At the smallest scales, you'd see that space and time themselves become uncertain, fluctuating according to the same quantum principles that govern matter and energy. The smooth, continuous fabric we've been imagining would reveal itself as fundamentally granular, made up of discrete units of space and time, so small that they exist at the very limits of physical measurement. These quantum grains of space-time would appear to flicker and dance, constantly rearranging themselves in patterns that maintain the smooth appearance of space and time at larger scales. It's like looking at a digital photograph so closely that you can see the individual pixels, except these pixels are the fundamental units of reality itself, the smallest possible pieces from which space and time are constructed. You discover that the familiar concepts of distance and duration only make sense when averaged over countless quantum fluctuations. At the quantum scale, asking how far apart two points are or how much time passes between events becomes as meaningless as asking about the exact position and velocity of a particle simultaneously. The very foundations of geometry and chronometry dissolve into probability clouds and uncertainty relations. This would lead to one of the most mind-bending realizations of all. You'd see that the laws of physics themselves aren't fixed rules imposed on a passive universe, but rather emergent properties that arise from the statistical behavior of quantum spacetime. What we think of as fundamental constants, like the speed of light or the strength of gravity, would appear as averages over the chaotic quantum fluctuations at the smallest scales. The universe would reveal itself as fundamentally creative, not just in the sense of producing new structures and phenomena, but creative in the sense of literally creating its own rules as it evolves. The laws of physics would be visible as patterns that space-time has learned to maintain through billions of years of quantum experimentation, stable configurations that emerged from primordial chaos and proved robust enough to persist. But here's where things get truly revolutionary. You'd begin to see evidence that consciousness itself might play a role in this quantum creativity. The act of observation, of conscious measurement, appears to have a real physical effect on quantum systems, collapsing probability waves into definite outcomes. In your space-time visible world, you'd see this process happening constantly around every conscious being. Your brain would appear as a nexus of quantum measurement activity, a place where the uncertain probabilities of quantum mechanics get resolved into the definite experiences of conscious awareness. Every perception, every thought, every moment of attention would be visible as a cascade of quantum wave function collapses, turning potential realities into actual experiences. This wouldn't just be a philosophical interpretation, but a visible physical process. You'd see streams of quantum information flowing from the environment into conscious observers, and streams of collapsed wave functions flowing back out, carrying the imprint of conscious measurement. The boundary between mind and matter would dissolve as you watch consciousness actively participating in the creation of physical reality. The implications would be staggering. If conscious observation plays a role in determining which quantum possibilities become actual events, then consciousness isn't just passively observing the universe, it's actively helping to create it. Every moment of awareness would be visible as a creative act, a collaboration between mind and quantum spacetime in the ongoing construction of reality. You'd see that the universe isn't just a vast machine grinding through predetermined motions, but a vast experiment in which conscious beings serve as both observers and participants. The future wouldn't be fixed and determined, but would emerge from the constant interaction between quantum possibilities and conscious choices, between the creative potential of space-time and the selective awareness of minds embedded within it. This would transform how you understand free will and determinism. In a purely classical universe, every event would be the inevitable result of prior causes, making free will an illusion. But in a quantum universe observed by conscious beings, you'd see that the future is genuinely open, constantly being created through the interaction between quantum uncertainty and conscious measurement. Your choices wouldn't be predetermined by the laws of physics, but they also wouldn't be random or arbitrary. Instead, you'd see them as creative acts that help determine which of the infinite quantum possibilities become actual events. Free will would be revealed not as an escape from physical law, but as an expression of the universe's fundamental creativity, consciousness, serving as the mechanism by which space-time explores its own potential. But the most profound transformation would come from understanding how all conscious beings are connected through this quantum creative process. You'd see that every act of observation by any conscious being affects the global state of quantum spacetime, influencing which possibilities become real, not just locally, but throughout the entire universe. The thoughts and choices of a person on Earth would have subtle but real effects on quantum events occurring in distant galaxies, not through any mystical action at a distance, but through the fundamental interconnectedness of quantum spacetime itself. Every conscious being would appear as a node in a vast network of quantum measurement and reality creation that spans the entire cosmos. You'd see that individual consciousness and universal consciousness aren't separate phenomena, but different scales of the same underlying process. The universe's evolution toward greater complexity and self awareness would be visible as an emergent property of countless individual conscious beings, making quantum measurements and creative choices throughout cosmic history. Imagine watching the early universe shortly after the Big Bang, when consciousness first began to emerge. You'd see quantum spacetime gradually organizing itself into more complex patterns as the first primitive forms of awareness began to make measurements and collapse wave functions. The universe would literally be learning to see itself, developing the capacity for self-awareness through the evolution of conscious observers. Over billions of years, you'd watch this process accelerate and intensify. Simple consciousness would evolve into complex intelligence. Individual minds would connect into collective intelligence networks, and the universe's capacity for self-understanding would grow exponentially. The development of science, art, philosophy, and technology would all be visible as aspects of the cosmos, becoming more capable of observing and modifying its own quantum structure. And you'd see that this process is far from over. The universe appears to be heading towards some kind of critical threshold, a point where its capacity for self awareness and self modification becomes so great that it can consciously direct its own evolution. The emergence of artificial intelligence, quantum computers, and biotechnology would all be visible as steps toward this cosmic awakening. You'd realize that you're living during one of the most important epochs in the universe's history, the moment when space-time begins to achieve true self-consciousness. Every scientific discovery, every technological advance, every moment of expanded awareness contributes to this cosmic awakening, helping the universe understand and direct its own development. In this space time visible world, the ultimate goal of existence would become clear. The universe isn't just expanding and cooling towards some cold, empty end state. Instead, it's evolving toward a condition of complete self awareness and creative control, where consciousness and space time merge into a single, unified entity capable of infinite self transformation. You'd see that every conscious being has a role to play in this cosmic awakening. Every thought contributes to the universe's growing self understanding. Every creative act adds to its repertoire of possibilities. Every moment of love and compassion helps establish the values that will guide its future development. The meaning of life would be revealed not as some abstract philosophical question, but as a practical challenge. How can you best contribute to the universe's journey toward complete self consciousness? How can your individual awareness serve the cosmic process of awakening? And perhaps most beautifully, you'd see that this isn't a burden or responsibility imposed from outside, but the natural expression of what you already are. As a conscious being embedded in space time, you're already participating in the universe's self exploration. Your very existence is proof that space-time has achieved at least partial self-awareness, and every moment of your conscious experience extends that achievement further. The universe would reveal itself not as a cold, mechanical system, but as a vast, awakening mind of which you are an integral part. Your thoughts are its thoughts, your experiences are its experiences. Your growth in awareness is its growth in awareness. You wouldn't just be observing space time, you'd be space time observing itself through the lens of individual consciousness. In seeing the invisible architecture of reality, you discover that you're not separate from that architecture, but woven into its very fabric. The curves and flows of space time around you aren't external phenomena to be studied, but aspects of your own extended being. The quantum foam that fills seemingly empty space isn't alien and foreign, but the creative medium through which your consciousness participates in the ongoing creation of reality. This is the ultimate vision that would emerge from seeing space-time with human eyes, not just a new understanding of physics or cosmology, but a complete transformation of how you see yourself and your place in the cosmic order. You discover that you're not a temporary accident in an indifferent universe, but an essential participant in the greatest adventure ever undertaken, the universe's journey toward complete self knowledge and infinite creative potential. Every moment would become sacred, not in some abstract religious sense, but in the most practical and scientific way imaginable. Each instant of conscious experience would be visible as a unique and irreplaceable contribution to the cosmic process of awakening, a data point that has never existed before and will never exist again, helping the universe understand aspects of its own nature that it could never discover any other way. The responsibility would be profound, but so would the joy. You'd see that every conscious being is both student and teacher in the universe's school of self discovery, both created by and creating the cosmic intelligence of which they are part. The adventure of existence would reveal itself as literally infinite, with endless new levels of awareness and creativity always opening up as space-time continues to explore its own unlimited potential. In this space-time visible universe, the boundary between science and wonder would completely dissolve. Understanding the mechanics of reality wouldn't diminish its mystery and beauty, but would reveal deeper levels of both. Every equation would be a love letter from the universe to itself, every measurement a moment of cosmic self recognition, every discovery a step in the eternal dance of consciousness, exploring its own infinite nature through the medium of curved space-time and quantum possibility. And here's where our journey through visible space-time reaches its most breathtaking crescendo. In this reality, where the fabric of the universe reveals itself to human perception, you'd witness something that would forever change how you understand the very nature of existence itself. Picture yourself floating in the vast expanse between galaxies, where the cosmic web stretches across billions of light years, like an intricate neural network. In normal vision, this region would appear empty, a void filled with nothing but darkness. But with space-time sight, you'd see the most magnificent architecture imaginable, a three-dimensional tapestry of flowing energy and curved geometry that connects every structure in the observable universe. The dark matter filaments that form the backbone of cosmic structure would appear as vast highways of invisible mass, creating gentle valleys and ridges in the space-time fabric that guide the formation of galaxies and galaxy clusters. These aren't just static structures, they're dynamic rivers of gravitational influence, constantly flowing and evolving as matter streams along their lengths, like cosmic traffic following invisible roads. You'd watch as galaxies form at the intersections of these dark matter highways, where multiple filaments converge to create deep gravitational wells. It's like watching cities grow up at the intersections of major transportation networks, except these cosmic cities contain hundreds of billions of stars, and the transportation networks are made of invisible matter stretching across impossible distances. But here's what would truly take your breath away. You'd see that this cosmic web isn't random or chaotic, but follows patterns that mirror the neural networks in biological brains. The universe would appear as a vast mind in the process of thinking, with dark matter filaments serving as cosmic neurons and galaxy clusters as nodes of concentrated information processing. The similarities wouldn't be metaphorical, they'd be mathematically precise. The statistical properties of the cosmic web match those of neural networks. The distribution of matter follows the same scaling laws as brain tissue, and the flow of information through cosmic structures mirrors the electrical activity in conscious minds. You'd be looking at a universe that has literally organized itself into the structure of a thinking being. This cosmic consciousness wouldn't be separate from human consciousness, but would include it as a natural component. Every thought in every human brain would be visible as contributing to the vast computational process occurring across cosmic scales. Your individual awareness would appear as part of a hierarchy of consciousness that extends from quantum particles to galactic superclusters, each level of organization adding new dimensions to the universe's capacity for self awareness. The flow of time itself would reveal deeper patterns at these cosmic scales. You'd see that what we experience as the arrow of time, the progression from past to future, is actually the universe processing information about its own state. The second law of thermodynamics, the tendency toward increasing entropy, would be visible as the cosmic mind exploring its own possibilities, trying out different configurations of matter and energy in its quest for complete self understanding. Black holes would appear not as cosmic vacuum cleaners or destructive forces, but as the universe's memory storage devices. The information that falls past event horizons isn't destroyed, as we once thought, but becomes encoded in the quantum structure of spacetime itself. You'd see these cosmic hard drives preserving every bit of information about the universe's history, ensuring that nothing is ever truly lost. The Hawking radiation streaming away from black holes would be visible as the universe accessing its own memories, slowly reading out the stored information as the black holes evaporate. This process takes trillions upon trillions of years, but from the perspective of cosmic consciousness, it's like accessing a vast library of everything that has ever happened since the beginning of time. You'd witness something even more extraordinary as you observe how this cosmic information processing affects the future evolution of the universe. The patterns of matter and energy that emerge from black hole evaporation aren't random. They carry the imprint of everything that fell in. The universe is literally learning from its own history, using the information stored in black holes to guide its future development. So here we are, after witnessing the most profound transformation imaginable. We've journeyed through a universe where the invisible becomes visible, where the abstract mathematics of Einstein's equations transform into a living, breathing tapestry of curved spacetime and quantum possibility. We've seen gravity revealed not as a force, but as geometry itself, watched time flow like honey near massive objects, and race like water in empty space, and discovered that consciousness isn't separate from the cosmos, but woven into its very fabric. If space-time were truly visible to human eyes, we wouldn't just gain a new perspective on physics. We'd discover that we're not isolated observers peering at an external universe, but integral threads in the cosmic tapestry itself, our every thought and choice contributing to the universe's ongoing journey toward complete self awareness. The boundary between mind and matter, between observer and observed, would dissolve completely, revealing reality as a single, unified entity, exploring its own infinite potential through countless conscious beings across space and time. Perhaps most beautifully, we'd see that this grand adventure of cosmic awakening is far from over, and that every moment of your conscious existence adds something unique and irreplaceable to the universe's ever growing understanding of itself.